Okay, let's dive right into this. If you're just stepping into the wild world of middle school physics, I need you to do me a massive favor. Completely forget everything you thought you knew about science class. Seriously, toss it out the window. We aren't here today to just memorize a bunch of boring textbook chapters. No way. We're going on a full-blown scientific quest. In this explainer, we're tackling your very first major physics topic, matter. But we're going to look at it like we're uncovering the invisible, secret building blocks of our entire universe. And trust me, by the time we wrap up, you won't just understand the universe better, you're going to see exactly how to totally crush those exams without ever feeling the pressure of mindless late-night memorization. Ready? Let's go. All right, to kick off our quest, we're actually banning a very strict rule today. We are officially banning the definition first rule. Yep, absolutely no boring textbook definitions allowed just yet. Instead, I want to present you with a mystery, a real-world impossibility. Think about this for a second. You can walk through the air in your living room right now and not feel a single thing, right? You can jump into a swimming pool and literally push the water out of your way with just a bit of effort. But if you try to walk straight through a solid brick wall, well, you're going to smash your nose and it is going to hurt. But why? I mean, they're all just stuff in the universe. Why does one let you pass, one slows you down, and one completely stops you dead in your tracks?
Well, to solve this mystery, we need to gather some clues. And guess what? We don't need a fancy multi-million-dollar science facility to do it. We're going to turn your very own kitchen into a top secret science lab, and you get to be the lead scientist. Honestly, the absolute best physics experiments happen right next to where you make your morning toast. So grab a grown-up, head on over to the kitchen, and let's start observing how this universe actually behaves. Okay, here is our step-by-step hands-on investigation. Step 1. Take an ice cube right out of the freezer. Hold it in your hand or just pop it on a plate. It's a solid, right? Notice how it completely holds its own shape. It doesn't care what shape your hand is. It stays a cube. Now, step 2. Throw that ice cube into a pan and gently heat it up until it melts into water, which is a liquid. Suddenly, boom, it completely loses its rigid shape and perfectly takes the shape of the bottom of the pan. Step 3. Turn up the heat and let that water boil until you see steam, which is a gas, rising up and escaping into the air, spreading out literally everywhere. And finally, step 4. Grab a cold lid and trap that steam. You'll actually see the gas condense right back into water droplets right before your eyes. All of this leads to one seriously amazing conclusion. You just witnessed the exact same stuff change into 3 entirely different forms. So, the absolutely crucial point here is this. What we just did in the kitchen is the perfect setup for the big reveal. Only now, after we've actually seen it with our own 2 eyes, do we look at the official science definition. Matter is simply anything that occupies space and has mass. That ice cube? Matter. The liquid water? Matter. The steam? Matter. Even the air you're breathing right now. It exists in 3 main states: solids, liquids, and gases. But here is the ultimate secret. What determines if it's a solid, liquid, or gas is simply how tightly packed its tiny invisible building blocks, which we call molecules, are. Suddenly, this super rigorous academic definition isn't just a string of confusing words to memorize, right? It's just the really satisfying answer to our awesome kitchen lab experiment. And this brilliantly illustrates the answer to our smash nose mystery from earlier. Why does the wall hurt but the air doesn't? It's all about this secret concept of molecular spacing. In a solid, like that terrible unforgiving brick wall, the tiny building blocks are packed together so tightly they literally cannot move away from each other. It's like they've locked hands and are standing shoulder to shoulder. So when your poor nose hits them, they do not budge. But in a liquid, like water, the molecules are a bit looser. They can kind of slide past one another, which is exactly why you can jump in and swim right through them. And in a gas, like air, the molecules are spread super far apart, just zipping around totally freely. You can literally walk right through the empty space between them. Mystery solved and noses saved. All right, now that we've unlocked the secrets of matter, let's talk about some cheat codes for exam success. I'm going to share 3 shortcuts to sneak this knowledge right into your brain effortlessly so you can ace 6th grade physics without the stress. Here are your 3 pro tips for becoming an absolute master at conceptual learning. First up, just like we did today, ban the definition first rule. Never, ever start studying a topic by trying to memorize the bold words in a textbook. Start with a question or observe something first. Second, maintain a physics logbook. And third, play the what-if game. You see, physics is fundamentally about curiosity. It's about understanding how the world actually works, not just getting marks on a piece of paper.
If you focus on the fundamentals and ask questions, the high marks are going to automatically follow. Let's look a little bit closer at that second secret.
I absolutely love this one, and I highly recommend setting up a dedicated physics logbook. Now, to be super clear, this is entirely separate from your regular schoolwork or your exam notebook. Your exam notebook can sometimes feel a little pressured, right? Like it's a place for stressful rote memorization where you feel like you have to get everything perfectly right. But your physics logbook, that is your completely safe, creative sandbox. There are absolutely no wrong answers in this logbook. Use it to draw messy doodles of your kitchen experiments, jot down spontaneous, totally confusing thoughts you have during the day, like, hey, why does my shadow get so much longer in the evening? Write down the weird things you observe. When you make learning physics a personal, creative space where it's perfectly fine to be messy or even wrong, the concepts stick in your memory way better than reading them 50 times from a textbook ever will. So, now you know the secrets of matter and exactly how to study it. Finally, to really test your new physics brain, let's play the what if game. This is hands down the best way to test if you truly understand a concept. For instance, when you get to your chapter on force, you're going to learn about friction, the invisible force that fights against motion. To really understand it, you don't just memorize it, you ask yourself, what if friction completely disappeared from Earth tomorrow? Just picture that wild scenario for a second. Every single time you tried to take a step, your foot would just slide right out from under you. You literally couldn't walk. Cars driving on the street wouldn't have any grip to brake, so they couldn't stop. If you pushed your textbook across your desk, it would slide off, hit the floor, and just keep sliding forever. Playing games like this makes physics incredibly fun and totally unforgettable. So keep asking those wild questions, keep experimenting in your kitchen, and you are absolutely going to dominate physics. Until next time, stay curious.